In this video, we will look on to the analysis of del operations. So in the del operations, we will first deal with what is del operator exactly mathematically defined by. Del is change, a small change, an infinitesimally small change. When del is operating on the scalar field, what is going to happen? When del is operating on the vector field, what is going to happen? So mathematical equation I have written over here. Del is equal to dou by dou x of I vector plus dou by dou I of j vector plus dou by dou k or dou z of k vector. It makes no difference. The function which we choose, it depends on. So with respect to x, with respect to y, what is the change which is going to happen? That is, what is your del? How to define this del? As in the previous slide spoken, del operating on a scalar field is called gradient. So gradient of any function f of x comma y comma z. So del f of x comma y comma z is called as gradient, which is the meaning df by dx comma df by dy comma df by dz. Now we can choose a function, for example f of x comma y comma z equal to x plus y square plus z cube. As the definition of gradient is very clear, I am differentiating the first term x with respect to x, so it is 1. I am differentiating the second term y square with respect to y, so it is 2y. And it is third term z cube differentiated with respect to z, so it is 3z square. Now in this, I can define the increase in the value of the function by choosing the current coordinates as 3, 4, 5, which means that with respect to any x value I have to substitute 3, with respect to any y value I have to substitute 4, and with respect to z value I have to substitute 5. So the equation is redefined as a direction of 1, 2 of 4, 3 of 5 square. So the final direction or the new vector would be 1, 8, 75. Now the gradient of the scalar field V is a vector which represents the magnitude and direction of the maximum space rate of increase of V, is the technical definition. So we can define this gradient of V as del of V in terms of Cartesian ordinate system, cylindrical ordinate system, spherical ordinate system. When we define it in terms of Cartesian ordinate system, it is moving along ax vector, ay vector, az vector. In cylindrical ordinate system, it moves along a rho vector, a phi vector and az vector. And in case of spherical ordinate, ar vector, a phi vector and a theta vector. Then comes the analysis of divergence. When del is operating on a vector field, it is called as either divergence or scale. Then it is operating via the dot product. Then it is called as divergence. So to represent what is basic definition of divergence, the second diagram is chosen. So if it is diverging, everything is diverging out. Converging is everything is converging in. This is the simplest surface map showing the convergence and the divergence. Next, the classification, how the divergence could be placed exactly practically is if del dot of V is less than 0, greater than 0, equal to 0. So that may lead to positive, negative and 0 divergence. For day-to-day example, we can imagine standing at the edge of the pond, sprinkling some sawdust. So if it is spreading out or if it is joining together, so it is defining the point where it is positive or negative divergence. So the basic equations, mathematical equations related to divergence are given in this slide. However, we have to learn the divergence of A is always denoted by del dot of A, which is limit of del V approaching towards 0, integral of any vector A dot surface integral of any vector A with respect to del V. As del V is approaching towards 0, it becomes a surface integration. So it can also be defined with respect to Cartesian ordinate, cylindrical ordinate and the spherical ordinate. And then is the last analysis of del operation called as curl, vector product. When del operates via vector product or cross product, then it is called as a curl, and it describes the circulation or rotation of vector field about that point. So for example, first example, in a box choosing some points of x, y, z, how the curl is rotating around has been shown in the arrowhead. And the second is a example right hand rule, where we have a current carrying wire and we are placing the hand over the current carrying wire, which is called as the right hand rule, where the thumb points the direction of current flow and the fingers pointing the direction of magnetic field. And this is the condition for mathematical analysis of curl in terms of Cartesian ordinate system, cylindrical ordinate system and the spherical ordinate system. However, all these equations you would have learnt in your schooling. Only the applications of these del operators we will be continuing with to take into the consideration of electromagnetic fields. So in the next video we will continue with. Thank you.